All right. Ooh, that's a bit loud. Good morning, everyone. It's good afternoon. Welcome to Build. My name's James Baker. Work in the data group in Azure. Today, I want to talk to you about a couple of things. You know, sort of Yarn ecosystem generally, and the applications that are available in the Yarn ecosystem, and how we can make those available to you in the HDInsight service that we run in Azure. So just a quick little primer around sort of Hadoop, sort of 101 type things, and where the Yarn ecosystem fits into the Hadoop ecosystem. So Hadoop 1 was all about MapReduce. We had some extra applications, but they were all around MapReduce. There was a couple of exceptions. For instance, HBase isn't a MapReduce type workload, but it was mostly about MapReduce. It was a fairly closed ecosystem. Yarn, Hadoop 2 came along, introduced us with Yarn. Yarn's a sort of a generalized resource management capability that makes a Hadoop cluster, or transforms a Hadoop cluster from being a MapReduce cluster into a general distributed workload, sort of data-centric workload cluster, but gives us that generalization. That capability in turn spawned a bunch of very interesting things around non-MapReduce workloads that suddenly started running on Hadoop, and is essentially what is driving Hadoop today. So when we sort of think about Hadoop and the relationship to Yarn, we think about some sort of different classes of applications. There's probably the sort of tier 1 application. They've been around in Hadoop from sort of more or less the beginning. HDInsight supports these guys as sort of primary SKUs, so you can get a SKU of HDInsight, you select and say, I want to run HBase on it, or I just want to run MapReduce, or I want to run Spark. And so these are well-known, well-loved, and quite frankly, this represents the majority of the workload that Hadoop's running today. But the sort of point about it is that it's no longer the only class of workload we've got, and people want to be able to take advantage of this style of MapReduce or sort of more traditional Hadoop workloads and integrate it in with other forms of processing to give a complete data manipulation or data management sort of stack end-to-end, and we can do that within the same cluster. So, just a couple of icons here. There are many, many more applications in there. You go out to the Apache website, or you go to many of, there's a number of public websites that talk about listing the applications that live in there. There's a very long list. Some of the sort of classic ones. OpenTSDB is a very popular workload. It's a time series engine that stores its data in HBase. Accumulo, TitanDB has now actually been acquired, or Aurelius has been now acquired by Cassandra, but the TitanDB graph engine is still very much within the workload. Drill, Phoenix, we're seeing a lot of great new things around. Impala, Killen. Killen's an interesting one. It's an OLAP multi-dimensional cube. So, that sort of idea of, that's a long way from what MapReduce gave us maybe 5 years ago. And so you can run these petabyte scale, highly distributed workloads, but do very different things with them. So that's great. And we're sort of going to use as a sort of a premise for this talk that you want to get in and use some of these applications as part of your end-to-end data management. And you may have already been using HDInsight. HDInsight, as a sort of a quick recap, is a fully managed distribution of Apache Hadoop running in Azure. It's fully managed in terms of you don't have to worry about making sure the VMs are still alive and make sure that the software's getting patched. The service does all that for you. Basically, you just turn on the cluster in the portal, run your workloads, and you can be reliant that the cluster itself is going to remain up and remain healthy. That's the value that the HDInsight service gives you. But as part of that, they sort of tend to lock things down a little bit. It's not that it's not accessible, it's just that it's difficult to get into. You sort of end up having to patch your cluster if you want to run a sort of an extra workload, and then you sort of get in this funny space of saying, oh, my cluster itself is a fully managed PaaS type service, but I'm running applications in that cluster that I have to sort of take care of myself because HDInsight isn't doing that for me. And this is where the key thing of what we want to do. The other thing about HDInsight is that it does give you a great sort of deployment story. It fully integrates into ARM. And that's a benefit. It fits really well into a DevOps workflow. You can be very sort of controlled, even check into source control, your sort of deployment artifacts. But the points of extension where you can go and install custom software are very, very limited. And so that's another challenge that we need to sort of work around. So this brings us to an interesting third piece. So Hortonworks, I want to say sort of 4 years ago, introduced a new service across the Hadoop distribution called Ambari. Ambari, in the same spirit of Hadoop becoming a general purpose distributed fabric, Ambari sort of managed that distributed fabric for us in a sort of a non-MapReduce centric way. So when you sort of think about the Azure Fabric Manager, think about Ambari doing much of that same sort of thing, but obviously at a very cluster local scale. Cool thing about it is that it's doing all of that management. It's allowing you to deploy applications across your cluster. It's monitoring those applications. It's reporting on the metrics. It's taking repair actions when things go awry, and it also gives you an interesting UX for things like configuration, and I've got a little bit out of order, but the configuration you can manage through the web UX, and we'll look at that in a second, as well as all of that monitoring capability. And so the great thing that this can deliver is that if I've got a way of installing an application into Ambari, then I can get back to that space of having a fully managed, a sort of automated managed, not only my cluster, but the applications as well. And so I don't have to get into the business of monitoring these things myself. Ambari does that all for me. So, and the last point I should add there is that HDInsight itself uses Ambari to deploy itself. And so it's a little bit of a sort of snake eating its tail type story, but that becomes significant when we look at what it means to go and deploy things with new services with Ambari, because we need to be cognizant that HDInsight's using that in itself. Cool, so let's just go and have a quick look. Just show of hands, how many people have used Ambari and sort of know about it? Great, all right, so this is a bit new to a few of you. So this is Ambari's web UX. This is running in an HDInsight cluster. As you can see up here, we've got the HDInsight suffix. So sort of get your mind around that all of the virtual machines in here and all of the software is being fully managed by the HDInsight service. But this service, the Ambari service, is taking care of all of these services down here. It's making sure they're all running. It's monitoring the processes on the designated hosts are going. It's making sure you've got declarative state around configuration and so on like that, and making sure there's no drift in configuration. And out of the box, you get all of these. This happens to be an HBase SKU for the HDInsight cluster, and so you get HBase, Hive, Oozie, Zookeeper. These are services that HDInsight deploys for us automatically. The interesting thing here is the OpenTSDB service. So that HDInsight has no relationship with OpenTSDB. And so that's something that we've gone and, or I've gone and added as part of the deployment of this cluster, added that service because I want to run a time series store workload throughout my cluster. Integrating that into Ambari is sort of basically what we're going to spend most of the time talking about. Other things that sort of worth looking at, you sort of get a feel for what we've got. first thing to notice is that, yeah, it's showing we've got what OpenTSDB calls the TSD service running on four hosts. They're all healthy, everything's good. It's got a reverse proxy there on the edge node, which is allowing me to load balance my traffic. Normally that'd be a metrics. It was working this morning, trust me, but it's not now. There's the demo gods. And it allows me to do things like control it. If I want to shut it down, I can just go through here, shut down OpenTSDB if I wanted to restart it, for instance, for whatever reason. The other thing I can do here is manage the configuration. So you get a sort of a version-controlled configuration experience with Ambari. Allows me to move forward in a predictable manner and move back if that configuration doesn't work. And I get some interesting sort of UX around doing the configuration. Also can go and add extra attributes in here myself. So that's the sort of Ambari web UX. One thing I will show in addition is that it allows the UX of the application itself to be hosted within the web UX sort of frame, if you like. So it does give you that sort of central point of management, but also interaction with the application. So this is not Ambari, this is Ambari hosting an iframe of the OpenTSDB web UX. And so whatever application I happen to choose, there's an opportunity to go and host a web UX in here. And that's fairly typical of the applications we're seeing in the Yarn ecosystem, and so it just becomes a very convenient thing. So that's great, and you know, like that's sort of fairly significant, getting to that state where everything's being managed for us. And there are a bunch of challenges in getting to that point, because as I say, you know, one of the things you give up a little bit when you use HDInsight is the flexibility to go and do anything to my cluster. I'm just sort of not running the machines anymore. And so as HDInsight comes and controls the cluster for me, there's a few things I give up. Luckily, they do give some discrete extension points, and we're going to go and look at how we go and extend those, use those extension points to go and deploy and wrap our application Ambari. The other thing we have to do is Ambari itself does require a bit of sort of wrapping of our application, because it's got a fairly specific thing, you know, to sort of drive all that web UX, to drive all of the management signals, you've got to go and configure your application, and we'll go and look at that now. So if we go, we've got a, doing this level of integration, I don't know, does anyone throw out a name of a Hadoop application that someone might want to integrate into a cluster? Anyone? Drill? Yeah, cool, all right. So Drill itself, I'm just trying to wind back. I think Drill just deploys, typically they just deploy by an archive. And you know, the applications will support different topologies. Some of them say, oh, okay, we want to be on the head nodes. Some will say we want to be on the worker nodes. Some will say, oh, we don't actually want to be on the cluster itself. We want to be on the side of the cluster. And so there are a variety of topologies you've got to think about, and you've got to sort of think about that as you're onboarding an application, saying, okay, well, you know, how exactly do I want it? And bear in mind there's a trade-off about sort of resource management that you're doing. If you install everything on the region node, suddenly your region node has less capacity to go and do things and do its I/O with HBase. So there's some choices there, but essentially what the challenge is, I've got some bits in an archive, I need to get them out across my cluster, I need them spun up and running, and then I need Ambari to go and monitor it for me, and I need to give it those points at which to go and monitor. That's essentially the task. One of the main entry points that Ambari requires of us is to mark up the metadata here. And so you can see here's the one we did for OpenTSDB, just give it a bit of display. Then it allows us to break the application down into components. And you remember when we looked at the web UX, we saw the TSD component, which is the time series daemon itself, which is doing the collection of the sample data and writing it to HBase. And then we've got another component down here, which is the proxy, which is that load balancing capability that we want. So we've got all of our TSDs spread out across all of our region nodes, but then if we've got traffic coming in from outside of the cluster, which is fairly typical in, say, an IoT scenario, you want to be able to sort of direct all your device information to an endpoint, have it load balance out across those TSDs, and get sort of super high throughput writing it that way. So we've got two components in the application. The other thing we have to do is say, okay, I've identified the components, Ambari, now I need to give you some code whereby you go and run this code for me and it'll go and deploy the bits. And so that's what we've got highlighted here, this opentsdb.python file. It's a relatively straightforward. Actually, the cool thing about Ambari is it's got a fairly sophisticated framework in itself. What it does is it has this resource management package which exposes a lot of general purpose functionality. You just sort of say, oh, I want to write a file, or I want to do, reboot a VM or something like that. There's a bunch of functionality in this package that delivers this. One of the things that it does is defines a base class which we have to derive from to or extend to go and do our specific pieces. So as we extend the script class, we have to go and implement the install method, and that's pretty much just get the bits down, unpack them in however the application needs to get unpacked, and then sort of set it up. In the case here of OpenTSDB, we just get a package down from GitHub, we uncrack it open, we update some configuration a little bit, we get a few more packages. This is a DPK package that we get down, and so on. We sort of just drive through, do whatever the application requires us to do to go and install it. There's also a configuration step that we need to go through, and that's just simply a matter of Ambari taking that configuration that was either managed defined through the web UX or via an API, and it's going to go and distribute that configuration out to all of the nodes out here. And so eventually this piece of code gets that configuration and writes the configuration or persists the configuration in whatever way the application needs to go and run. In this case, it's about writing out some properties files. And so again, we've got some general purpose functionality which writes a sort of .ini style file which a lot of these components use. Then there's the sort of control stuff, the start and stop stuff, which is, it's not trivial, but it's relatively straightforward what you've got to go and do. In this case, we've set it up as a systemd service, and the other interesting thing is that we've set up a metrics service that goes and reports the metrics of this specific TSD process to the metrics collector, which is what drives the Ambari behavior. And that's more or less sort of all you need to do. There is configuration information. This is, again, what's driving the web UX around the configuration. So there's, you can give lots of help information and so on like that if your users need that sort of stuff. But not a huge amount of work. It's sort of more like, oh, I need to transcribe the configuration that I know the application needs into an XML, give it the right sort of metadata, and away we go. So that's the process of wrapping the application in Ambari's requirements. The next step in the process is saying, okay, what's HDInsight need to go and make this happen? So remember, HDInsight doesn't know about this application. We're going to take advantage of the one extension point during deployment and go and sort of install this stuff up. So the first thing we need to go and do, we've built a framework, and there'll be a link in the deck about a general purpose framework that you can go and write some configuration for, and specify the only applications that you want to use. We're also going to go and sort of have a gallery of applications that we've already done this work for. OpenTSDB's there, TitanDB's there, Killen's there, and we'll grow that list as we sort of see more and more applications. But essentially, the process is fairly straightforward. Again, we sort of define the configurations the components that we need. We specify where the zip files coming, or the archive's coming from, and that is the archive of the wrapper that we've done, not OpenTSDB itself, but just the Ambari wrappers, the pieces that we've put in there. We give it its initial configuration, and more or less we're off to the races. Then it's a case of, okay, well, how do I integrate that into my deployment? It's fairly simple, really. This is an ARM script for a standard HDInsight deployment. We've gone and extended it. The one extension point is the script actions piece, which allows us to go and run a bash script. This component here, this bash script, is a shared standard component, which in turn calls a shared Python script, and we parameterize it with that configuration information that we look at. And more or less that's the end of it. You know, you incorporate this into your HDInsight deployment, and then you get that experience that we saw before, where the Ambari Web UX is showing the service there. It's as sort of a peer first class or peer service of all of those other ones, Hive and HBase, and is managed in the same way. And it's probably just as a little sort of piece. I'll give you an example. This again is the same cluster that's running it. We're on one of the worker nodes. If I was to sort of kill off the TSDB process, so imagine it's just died for whatever reason. If we flip back into here, very shortly we'll see that Ambari's detected that failure, and it'll alert us. We can describe repair capability of saying, okay, just if you see this service fail, immediately restart. Here we go, we've stopped it. It said on this particular node, the process has stopped. You know, we can take the remediation. I can't wait for the remediation, but I can simply just restart that directly there, or I can have it automatically restart. So that's an example of how you get that PaaS-like behavior of Ambari monitoring and managing the application for you. So, I think that's about it. What have we got left? So, I'd certainly encourage you to go and use HDInsight if you haven't done that. It's a fantastic service to run your Hadoop clusters. That fully managed capability is great. Integrate your Yarn applications into Ambari, into HDInsight, either using the pre-existing ones or feel free to wrap your own. We've got the instructions on this GitHub about how to integrate into the framework that we've written. We will add more applications into that repo so that there's more choices available there. And then we're sort of going to continue on. I mean, you know, one of the major value pieces of HDInsight is that it is open, it is the real Hadoop distribution, and so we want to be able to let you take full advantage of what that means in terms of an open platform and a sort of a growing, accelerating, innovative platform that Hadoop continues to be. Thanks very much.